SDWAN component. So VBON, the authenticator, we manage the NMS solution inside SD-WAN, vSmart, the centralized control plane, WAN edges, which needs a data plane connectivity with each other. So how do we deploy them? vSmart, VBond, vManage, they are also known as controllers. There are two things: controllers and forwarding devices. VBond, vSmart, vManage controllers. WAN edges are the forwarding devices. Controllers can be deployed on-prem or in the cloud. As I told you, since these controllers are in virtual form factors, can be deployed in cloud infrastructure or deployed on on-prem as a virtual machine. So physical server, the hypervisor layer on ESXi or KVM, VM1, VBON, VM2, vManage, VM3, vSmart, VM4, vSmart 2. On provided infrastructure, maybe like a cloud provided infrastructure, Cisco provided VM1, VM2, VM3, VM4s. When we have hardware, maybe like Vanages, so Vanages with various platform support. But the main thing what we need to understand it here, we have V edges and then C edges. So V edges are the Viptela devices. So Viptela hardwares and then Viptela software based routers, and then C edges are Cisco devices. Okay, so this is like Cisco boxes. So V8Gs nowadays, Cisco, doesn't ship Viptela boxes. Cisco supports Cisco boxes, but any existing customer infrastructure is, acquired, or existing customer infrastructure to be supported with the Viptela boxes. Still, we can say V8Gs 100, V8Gs 1000, V8Gs 2000, like. So Viptela V8Gs and then Cisco C8Gs, and both will be available in physical and then virtual form factor. Viptela, we could find VH100, VH1000, VH2000, 5000, like physical boxes. And similar way, we have VH Cloud. So VH Cloud is Viptela OS based virtual router. So we can say like virtual machine is deployed as a virtual router. In it, Viptela OS and Viptela specific configuration commands we will apply it. So both virtual and then physical form factor for Viptela VHS. Similarly, CHs, even Cisco has physical form factor and then virtual form factor. And in case of physical form factor, ISR and then ISR 1000 and then ISR 4000, ASR 1000. So we do have the models, dedicated models supported for physical infrastructure, and ISR virtual, CSR virtual. So we do have virtual form factor for the Cisco boxes as well. Okay, so C edges, Cisco boxes, V edges, Viptela boxes are supported in both virtual and then physical form factor. It depends. It depends on the model, number of LAN interfaces or the devices to be present with WAN interfaces. So number of LAN interfaces and then throughput available between them changes. But apart from that, a basic nature, all the virtual and then physical form factors are available with LAN WAN interfaces, and they will be classified into VPN 0 or VPN 512, VPN 512, and then the service VPNs. So service VPNs. 1 to 511. So VPN 0 is for the transport, so transport reachability, ISP connections. VPN 512 is management for OOB reachability into these devices. Service VPN towards to the LAN side, so local network side or towards the LAN side. So virtual router will be initialized with VPN 0, VPN 512, and then service VPN. Physical routers can be initialized with VPN 0, VPN 512, and then service VPNs. So devices wise, we have both physical and then virtual form factor from Cisco as well as from Viptela. Some of them, examples like VH100, um, 5, 10, 100. 1000 Mbps RJ45, VH1008 1 gig SFE interfaces, 4 1 gig, and then network interface module supported. So PoE ports and 4G LTE interfaces, console port, management port, and other component. So hardware wise, they don't look similar. They don't look different. They look similar, like a console port is present, management port is present, plus data plane interfaces present for LAN and then WAN communications. Okay, so the first deployment will be on the controller. It's a VM, a vBond. First example is vBond cloud on-prem deployment, separate interface for control and then management. So this virtual machine to be initialized with the two VM NIC interface, and this two VM NIC interface will participate in two dedicated VPNs. So VRF 0 or VPN 0, and then VPN 512 or VRF 512. So control interface in VPN 0, management interface in VPN 512. And this control interface is with its unique IP configuration and gateway configuration, and also a specific DNS configurations. And using this IP gateway and then DNS, this VPN 0 control interface will be used to talk with other component. So using control interface IP, vBond communicates with the vManage, communicates with the vSmart, and then communicates with Vanages. So VPN 512, this is like OOB, like out of band management access. So logging into vBond console, I mean, maybe like SSH access. Via SSH we can be able to verify certain commands. So OB management access through management interface. So two dedicated VPNs and two dedicated interfaces, and the interfaces and devices to be initialized with minimal configuration. This is very important. vBond to be deployed on a fabric, or vManage, vSmart Vanages to be deployed on a fabric, it needs minimum configuration. So this minimum configuration is connectivity. Connectivity is like pointing. Okay, so at least one interface in VPN 0, the control interface, IP configuration, gateway, DNS configuration, plus system configuration. So this device specific information as system, and in this system IP address, the way unique router ID is identified by the routing protocol, same way every SDWAN component is identified using its system IP address. So unique system IP address for an hierarchical representation, what site they belong into it, organization name to trust the certificate or to validate the incoming digital certificate. So certificates organization name against the locally configured organization name under the system. So these organization names are matched to check whether the certificate is to be validated or certificate is not to be validated. So to be honest, like in SD-WAN, the components will receive the device certificate. From the device certificate, this is having the organization matching or not, organization name of the certificate against the local one, chassis ID and available on the local whitelisted database, serial number of the certificate and against the whitelisted entry. So incoming certificate, chassis ID, serial number, and organization name is matched against the localized entries. So just to validate the certificate, they must be configured with manual organization name under the system, then vBond IP address, because we don't need any other component, any other informations to address it, but under the minimum configuration vBond, to which vBond this device is going to connect, so that after authentication and then authorization, it can be provisioned automatically. So minimum of one interface with VPN 0 about IP, mask, gateway, DNS, and the reachability towards to the other component, and system settings for system IP, site ID, organization name, and vBond IP addresses. So these are the minimum configurations we need to do it. These configurations are manually provided to the device for manual deployment, or in automated procedure. These configurations are automated. vManage will push interface IP configuration. vmanage will push system specific configuration automatically based on that ZTP or PNP will be provisioned towards to it. So vbound as a virtual machine can be deployed on the hypervisor layer, and two interfaces will be placed into two dedicated VRFs, and then minimum configurations are required for this device to talk with others, and similarly like to identify this device into the fabric.
This slide talks about only vbound, right?
Same infrastructure will come for vmanage and then vsmart, the others, but this talks about only vbound.
So if you see the headline, it says controller deployment. So are we calling vbound and vsmart both are the controller?
Yes, vbound is called as a controller, vsmart is also called as a controller, even vmanage is also called as a controller. So these three components are controllers, and vanages are the forwarding devices.
Okay.
And these details we need to provide, I mean, configure manually through CLI or something into the vbond.
Yes, yes. Okay, suppose I have ESXi. On the ESXi, this new virtual machine is deployed. Okay, again, it will go to initial configuration dialog, but this will ask you the host name for this and login credential, login password we will try to do. Then this will ask you which interface is into control VPN, and then which interface into VPN 512, and IP address for this control port, and then IP address for management port plus system. So I think I have some slides pasted here. Some basic commands I can show you here. Maybe at this place you can see it. And once our device is initialized, when the VM is booted, so we manage user login. The default username and password is admin and then admin. Once this is booted, it will go into the initial mode. Same Cisco command, user privileged mode, configuration mode, subconfiguration mode, config terminal, configuration mode, VPN 512, VPN 0. We created default route in the VPN 0, DNS information. Interface ETH0 is called into VPN 0, ETH0 specific IP, and then mask, we commit the configuration change. VPN 512 interface is called VPN 512 with a default route, IP address, and then the configurations. Then we will have to give a system specific configuration. Under the system IP address for the device, site ID for this device, organization name, which is locally defined to trust the validate the certificate. VBond. In this place, we can give either IP address or fully qualified domain name and NTP. So system IP is mandatory, site ID is mandatory, even VBond IP address is mandatory, organization name is also mandatory. Otherwise, certificate validation won't take it place. So this initial configurations we must provide. Then this can be like using the system IP will be initialized, and then we'll talk to this vbound IP to authenticate. And if vbound provides any certificate, it uses the organization name to validate. If organization name matches, and then from this certificate, from this vbound certificate, and then this is going to complete the authentication and then authorization channels in it. But we have to provide the minimum configuration for VPN 0, VPN 512, and then system. At least VPN 0. This is mandatory. VPN 512 is for management purpose. Okay, even after that also we can be able to initialize it. But system and VPN 0, these two initial configurations are mandatory.
So we
So
need to, I mean, we need to provide this configuration to all the three controllers, right? Manually through
yeah,
CLI.
that's right. Manually through CLI, we will have to do that. Let's say
And
you, yeah,
mhm.
yeah.
And that organization name. So this organization name will be embedded in the device certificate itself also. I mean, the
Yes,
organization. Mhm.
yes, yes. So while we are obtaining the certificate for vmanage or vbound or vsmart or even for the vanages, we must make sure that the certificate organization name matches with the one which is we are going to configure on the devices. The organization name mismatches, certificate is not validated, then trust will not be built, then this device is not included as part of the fabric. So it must
So
match.
so in case if we are using public CA. and not enterprise CA. So in that case, while using public CA, we need to provide this organization name and all this information to the public authority body as well.
Yes, irrespective of whether we make whether we use internal CA or external CA, when the CA is signing the certificate to these devices, we must make sure that certificate contains the organization name of the one what we are expected.
So if we are going to use semantic, for example, then we need to, I mean, we need to provide these details to semantic, right? The
Oh, obviously.
organization name and all.
Yes. But that option is eliminated by generating the local CSR. The Viptela or any device which is participating in the certificate hierarchy, like WAN edges or controllers, they generate public key, private key. Public key will be copied into CSR, certificate signing request. Along with that, whatever the organization name or subject or the contact information, like organization specific informations to be included, we generate locally and we pass the CSR to certificate authority, and CA will sign it. When it signs, the certificate will be available with the organization name what we selected. So we choose and we generate our CSR by making our organization name or our information available in it. Once the CSR is signed by the CA, and we will be written with the certificate of the specified informations.
Okay, and here in this slide, I mean, under this minimal configuration, here is vbond IP. So, I mean, within vbond itself, also we need to provide this vbond IP, something like that.
Yes. So VBond itself should authenticate the device. For example, VBond will authenticate it itself, and vManage should be authenticate with vManage. So like VBond will give a local IP. That means go and then authenticate yourself with your infrastructure, because we are going to whitelist the VBond also into the fabric.
So, same way we need to provide the vmanage IP address to vmanage itself, and likewise to vsmart as well. Is it?
No. So every device is configured with only vbound IP address. We never configure vmanage or vsmart IP addresses to others. For example, VH, I'm going to provide a minimal configuration. VH, one interface with VPN 0, IP mask gateway reachability. Then system configuration. In system, I configure only vbound IP address. So VH will be authenticated by vbound, and vbound provides it. Okay, you are authenticated successfully and you are authorized to connect with, this is the vmanage IP address and this is the vsmart IP address. So after the information received from the vbound, and vedges will talk to vmanage, and then vedges will talk to vsmart.
Do you have any upcoming slides for the device discovery steps?
Yeah, everything is available.
Yeah.
Only thing is, I will do it one by one here. Okay, so the same flow will be maintained for vSmarts. So we do have vSmart control interface, control VPN, management interface, management VPN. So two interfaces and then two VPN, minimal configuration, connectivity IP to VPN 0, system IP, site ID, organization name, and vbound IP address. Same way, when I go with vmanage will be with a small difference. It has got three interfaces, one on VPN 0, one on VPN 512. Third is for the cluster communication, because vmanage is a one which is going to store all the configuration information. So configuration synchronization to take place from one vmanage to another vmanage within the cluster, it needs a communications path. So we initialize the third interface as the cluster interface, and we provide the layer 2 IP. That means they will be on the layer 2 boundary, and based on the layer 2 boundary, like the same subnetted communication from one we manage to other, they will sync the configurations. So minimal configurations for bring up, connectivity, and then system, and internal cluster interface for vmanage instance clustering, separate VPNs for control and then management, separate VPNs. So three interfaces, two interfaces in VPN respect to VPN, and third interface for cluster communications.
interface, I mean, only we need to configure only if we are having one more vManage in the system, right? And in cluster.
That's right. Suppose if you go for a single, we manage, I don't need any redundancy, lab environment or testing environment. We don't have to initialize this cluster interface. So we can initialize this VM can go with first interface and VPN 0 control interface, second interface into VPN 512.
And
Okay, I have one question. Does the system IP here reflect the like router ID?
Yes. So system IP address is an unique IP address equivalent to router ID and available and mandatory for all the component. So one small difference here, when we are configuring a router ID for the routing protocol, then entry will
Mhm.
not be created in the sense like the logical interfaces will not be created. But in case of SD-WAN, once we configure an IP address as a system IP address, then logical entry would be created. Like the way like loopback zero interfaces are created, then system IP address will be created with a logical interface. So this interface will become active, and this IP address will be like initialized for the fabric communications. Every device is identified with unique system IP address. Without system IP, no device is recognized, and then no device is allowed to participate with other devices, any kinds of plain communications. So this is mandatory, and duplications are not supported. Uniqueness is maintained, and there is no requirement that this system IP addresses should be reachable with each other. Just for uniqueness, we do create. There is no need for reachability, and we don't have to provide any routing communications for the system IP addresses.
Okay, and this site ID is across the environment is same or it is differ.
It is a hierarchical design. For example, I'm building a site in Bangalore. So Bangalore will be one site ID. Another site is built in, for example, Mumbai, again, new site ID. In US, a different site ID. The
Got it.
regions. So why this site ID we are trying to use it to enforce policies. I want to give a dedicated route filtering and then route policies for APEC sites, and dedicated route filtering or dedicated policies to be enforced at American regions or whatever, maybe like hierarchical representation and hierarchical policy enforcements we try to do. We will enforce them through site IDs.
Okay, and one last question is, whenever the device is authenticated with my vBond, after the authentication successful, we won't share the IP address of the vSmart as well as vManage both.
Yes, yes, it does. Yeah. So VBond is a one
Hmm.
distributes other controller information to managers. That means if a device to know the other controllers we manage and then vSmart, it must be authentic. You are authenticated, then you get these details. So you go and then talk to your vManage, you go and then talk to your vSmart, you participate inside the fabric. If not, restricted at VBond level itself.